Okay.
Yeah.
Where are you from?
I'm from Germany as well.
Okay, 2 people from Germany, 1 from France. I'm expecting more students, so they will show up eventually. So again, my name is Claudio Acuna, if you pronounce correctly. I'm a professor from Chemical Engineering Department. My background is more mineral processing, process control, and recently we started with this course on sustainable engineering, which is a very important topic for us at the Chemical and Environmental Engineering Department, where we have 2 programs, chemical engineering and environmental engineering, and related with sustainable development. We just signed an agreement with Alberta University in Canada in order to have a PhD program in this sustainable engineering. In addition to that, we just applied to an Erasmus program in order to have a program on a master degree on sustainable mineral processing. So everything is sustainable. Just to be very brief on that. In our case, since we are process engineers, since we are in Santa Maria University, we are more technical, so we'll see more technological stuff. I have some experience in water, involved in 2 water research centers, with some works on a circular economy that you will see in this course. This is an introduction to sustainable engineering, so it's for first-year students. However, there are some activities that you'll be conducting. So in this presentation, first of all, I'm going to introduce and invite you to think about what is sustainability, stuff like that. Then in the middle of the course, we will talk about the topics of the course and how it's going to be evaluated and the products. So this course is interactive, so I'm asking some specific people. Everything is recorded, including your own comments, in order to track your work. So we have a special guest here, my colleague and dear friend, Fernando Sperges. He's also a part-time professor with a lot of experience from industry. He has been working for more than 20 years in industry, contaminating and also taking care of the industry and impacting society. So it's very good to having a guy with a lot of experience, especially regulations and stuff like that. Okay, so far, let's start. So everybody is seeing the PowerPoint presentation in the full screen?
Yeah.
Full screen PowerPoint presentation. So I'm gonna, in my window, I'm gonna close your videos in order to make it easier. And I'm seeing in another screen here. I'm also seeing you. Okay, so first of all, we need to talk about current problems. In this following picture, we see some things regarding, let's say, what do we mean to having this picture on the right corner, upper corner? What do you think is going on there, Antoine?
Yeah, it's like after a New Yorker, I think.
Yeah. Why do you think I put this picture here?
Because it's I don't know say in English, some problem with the weather, and so you have to fight with no challenge, I think.
We are talking about climate change. And the important thing, we also can complain about climate change. We can be desperate about climate change. But in this case, we want to do, what are we going to do with climate change? We need to adapt, we need to develop technologies. That's the thing. So that's the difference with this course. So we want to be more active and proactive, not only complaining. So just to focus. What can we do about this, the left-hand side picture? Let's say, Maximilian. I'm going to translate that if you cannot follow. Let me read it. Chile suffering and hydric stress. Now it's an extreme event. This is a picture of an actual lake that is completely dry. So why don't you tell me what can you see what is happening, especially in Chile?
I think you can see like the results of the climate change. yeah, as well as the hurricane as well. Yeah, extreme weather conditions are a result of the current climate change.
What can we do about it?
Yeah, try to prevent it and find technologies to improve our behavior and our impact on nature.
Okay, there are some technologies that can harvest rain, for example. It's a good idea in countries like India, perhaps in even in Antofagasta and some events. However, it's kind of difficult. So are any of you familiar with reverse osmosis? Since we have a lot of mechanical engineers, I think you should have it. If you have any approach to reverse osmosis process? Any of you? You can say yes or no, by the way.
No, I never heard it.
No.
Okay, I'm glad that you don't know anything about that because we will be talking about reverse osmosis. Just to make it simple, reverse osmosis is a process where you can take seawater and produce potable water. It's a technology with about 20 years. It has been improved a lot in terms of energy consumption. But basically, you can produce a cubic meter of potable water starting from seawater with a cost of, okay, can you guess how much that it cost to generate a 1 cubic meter starting from raw sea water to generate at the door of the plant 1 cubic meter? How much that it cost? Can you tell me, Lionel?
Leo?
Guess a number. Leo, a number.
Yeah.
A rough number.
I would say like $4.
Okay, good guess. What about you, Maximilian?
Say a little more. I don't know, like 20.
20, good. Okay, Antoine?
Just to be the middle, I'm going to say 10.
Okay, believe it or not, it's $1.2. It's about $1, including, listen that, including CapEx, meaning the equipments, and operational cost, which mainly is electricity. So the technology has been improved a lot from the beginning. The energy consumption started from 20 kilowatt hour per cubic meter and down to now 3.2 kilowatt hour per cubic meter. The expensive thing is to pumping out from the sea level to high altitude, but if you have a plant by the coast, it's that cheap. I expect you don't believe me. That is good. I'm gladly share you an article from Chemical Engineering, and I'm gladly share you an article that I wrote about 20 years ago, where I made the calculation, and still it's about $1.2 per cubic meter, where 60% of the operational cost is electricity. So this calculation was made considering a cost of electricity of $60 a megawatt hour, okay? So if you reduce the cost of electricity, let's say renewable energies and so on, and technologies, you can have cheaper cost of water. So what is the main conclusion here? We don't have problem with water. We only have problem with energy, energy, and energy. So if we have energy, cheap energy, we have already the technology to solve this problem of water, okay? How cool is that? How cool is that?
Cool.
Very cool. So we will talk about that in the chapter of circular economy. Okay, but I don't want to be stopped here. So let's see the next picture regarding these nice seagulls. You know what is a seagull? In Spanish, you say gaviota. Seagull. So what can you tell me about, let's say, Maximilian, about this picture, right-hand side, lower side.
think it shows a lot of garbage just thrown out into nature, and not really taken care of.
Okay, this is the complaining view, which is also good because we are taking care of our environment. This is good. I agree with that. However, I'm seeing something different. I'm seeing here that we are wasting materials. We're wasting materials. We have bags, we have wood, we have organic material, perhaps some electronic scrap. So our mission as engineers is to take all these elements, classify, and get good stuff from that. Okay, let's say, for example, you want to recycle wood, you want to recycle even concrete from an urban site. One of the most intensive amount of residues are from the construction. About 30% of the mass come from construction, which are material that to be used as a raw material again. So we were talking about this in this course in something called circular economy. I will see some examples, the thing that we have done about that. So this is more or less the thing that we want to discuss in the course. And I'm gonna stop this video. I wanna